Imagine applying for a challenging new job today. You put your entire history into a resume. You submit it, then you get rejected by a cold calculating machine. Beat. But here is the part that keeps me up at night. You suddenly realize that single algorithm just secretly blacklisted you everywhere. It blocked you from 100 completely different companies, and no human being ever knew it happened.
It is a profoundly chilling thought, especially when you realize it is already happening.
Welcome to today's deep dive. I am really glad you're joining us for this one. We have got a fascinating stack of research to unpack today.
We really do. Today, we're exploring the extreme scaling of the new tech landscape. We will start with how physical hardware is being radically re-engineered. Then we will move into the mind-bending scale of modern AI software. And finally, we will look at the systemic dangers when these massive systems make decisions about human lives.
I want to start with the physical layer. Because before AI can scale globally, it needs physical pathways. And geopolitics has forced some massive, almost desperate hardware innovation recently, specifically with Huawei. They're essentially bypassing the classic Moore's law.
Right. For decades, Moore's law was the golden rule. It basically states that computer processing power doubles every 2 years. It is mostly about shrinking the actual transistor size. But Huawei is in a very unique position. They are completely cut off from TSMC.
TSMC being the world's top chip manufacturer.
Exactly. Huawei physically lacks the advanced lithography tools to print those microscopic circuits.
So they cannot just make the tiny brains of the chip smaller. They had to rethink the entire physical architecture from scratch. Beat. They are introducing something called the Tau Scaling Law. A lot of folks in the industry are actually nicknaming it Her's Law.
And the core idea here is brilliant in its simplicity. If you cannot shrink the transistors, you shrink the time it takes for electrical signals to travel between them. They are focusing entirely on the pathways inside the machine.
Let's unpack how they actually do that, because they use this clever trick called LogicFolding. It is a highly specific circuit-level design hack. Essentially, they fold in place related logic blocks much closer together.
Yeah, it is a total spatial redesign. This approach massively reduces internal electrical resistance. It also drops what engineers call parasitic capacitance, that is basically unwanted energy loss between closely packed wires.
Which is a huge issue at that microscopic scale.
Oh, absolutely. By folding the logic, they just make the critical internal wires much shorter.
I loved the analogy in our research for this. It's like, if we can't make the cars any smaller, let's just make the highway perfectly straight 2-sec silence. But I am trying to visualize this practically. Does shrinking the wires truly compensate for having physically larger transistors?
Well, it doesn't entirely replace raw, pure density. You still want smaller transistors if you can get them. But it is an incredibly clever survival tactic. It focuses purely on signal speed and extreme efficiency. By optimizing the commute, you make the whole city run faster.
So it's about signal speed, not just raw transistor size.
Yeah.
Beat.
Exactly. And it is a total paradigm shift for them. Their goal is to reach 1.4 nanometer class density by 2031. And they claim they have already built 381 chips using this exact thinking.
Being forced into a corner really created a totally new pathway. They're putting this in their next Kirin phone chip. It will be the first full test in the wild. I am going to be watching those benchmark tests very closely.
It is a massive gamble for their engineering team. Whether this becomes an industry standard remains to be seen, but it is an amazing response to intense geopolitical pressure.
While Huawei reorganizes those physical pathways, something else is happening on top of it. The software running on global hardware is scaling at a speed that is, honestly, incomprehensible.
The financial and usage numbers alone are just staggering. Take OpenRouter, for example. It is a major AI model hub. They just raised $113 million. They exploded in popularity recently. They now serve around 8 million developers.
And the volume of data they handle is what really stopped me in my tracks. Their single API processes an incredible 1.5 quadrillion AI tokens annually.
Just to clarify for everyone, a token is just a basic chunk of a processed word. But still, whoa, imagine scaling to 1.5 quadrillion tokens. The sheer infrastructure required to route that traffic is insane.
It is hard to even wrap your head around that volume. And the foundational models driving that traffic are evolving rapidly, too. Just look at Qwen. Their smartest model, Qwen 3.7 Max, just officially landed in their Go plan.
Yes, and its capabilities are wild. It effortlessly handles 2,000-page contexts in a single prompt. More impressively, it can run autonomous agents for 35 hours straight.
I still wrestle with prompt drift myself. 2-sec silence. When the AI just forgets its original instructions after 10 minutes. It is wild to think about a system maintaining pure focus for 35 hours. It even plugs directly into the Claude Code ecosystem now.
We are also seeing massive leaps in abstract reasoning. Anthropic's researcher Sholto Douglas revealed something huge recently. Their Mythos model successfully solved the famous Air-Doom problem number 90.
Right. It achieved the exact same mathematical result as GPT 5.5. But it did so with this remarkably cute, simple proof. It wasn't just brute force calculation. The math capabilities are reaching a new tier of actual reasoning.
And startups are heavily capitalizing on this momentum. There's a company called Trajectory that just raised $15 million. It was founded by former researchers from OpenAI, Apple, and Google DeepMind.
Their primary goal connects right back to that idea of reasoning. They want to build AI that improves itself from real user feedback. The distance between a user correcting the model and the model permanently improving is shrinking fast.
We are also seeing this intelligence bleed into the physical world. Figure AI just signed a massive deployment deal. They are putting humanoid robots inside Catalyst Brand's logistics network.
This brings autonomous agents directly into the physical supply chain. The source notes JCPenney warehouses might be the next target. Brooks Brothers warehouses are also on that potential deployment list.
It really shows how rapidly software is automating the physical world. But meanwhile, on the consumer side, companies are locking these powerful features behind paywalls. Meta now has paid plans across their entire social ecosystem.
If you use Instagram, Facebook, or WhatsApp, they're all getting premium AI access. These paid tiers unlock extra creator tools. You get custom profiles, advanced analytics, and deeper generative features.
It is deeply integrating AI into daily social media habits, and specific utility tools are multiplying rapidly as well. Blue Dot 2.1 is a great example of this trend.
It is fascinating workflow. It records conversations directly from your personal Apple Watch. Then it syncs them with Claude through the MCP protocol. MCP is a bridge connecting AI to external tools.
It is totally seamless data capture right from your wrist. Powerbase is another powerful new tool hitting the market. It basically builds AI apps using Postgres databases and RAG.
RAG gives an AI a custom memory bank to read from.
Exactly. Powerbase handles that memory, the workflows, and the automation primitives in one single platform. It is a very clean setup.
Another integration tool I found fascinating is a platform called Zero.xyz. It gives your AI agent massive external access capabilities. It connects to roughly 8,000 different tools and APIs.
Yeah, it can securely access services like Claude Code and Codex. It links up seamlessly with Gemini. It even talks to CLI agents. CLI agents are text-based command line tools.
With all this data flowing, there is also a strong push for user privacy. Oasis browser caught my eye. It is a privacy-first AI browser that you can train locally. You train it anonymously, ensuring your personal data remains on your machine.
But amid all this breathtaking scale, there is a weird reality check. There are still glaring, almost comical flaws in these systems. For instance, Google's AI overview still cannot reliably count letters in simple words.
There's this weird paradox I cannot get over. Beat. It's actually quite funny to look at the examples. At one point, Google's AI claimed the word Google has two P's. It also spelled Trump as TRPUM. And people just found a new obvious phrase that exposes AI writing instantly. It isn't the M dash, as many folks suspected.
Right, and it just shatters the illusion of intelligence for a second. It really does.
Exactly. How can we have models solving Erdo's math problems while failing to count letters in a basic word?
It comes down to how they see the world. Complex reasoning patterns are vastly different from basic token-level spelling mechanics. They process abstract mathematical concepts beautifully, but they don't actually see individual alphabetical characters the way we do.
Right. Massive logical reasoning doesn't mean it understands basic spelling. Beat.
Precisely. It is a fundamental quirk of how neural networks parse information. They predict chunks of meaning, not individual letters.
We're going to pause right here. We will continue our deep dive right after this. Sponsor. So, we just talked about AI spelling Google with two P's. The quirky unreliability of spelling mistakes stops being funny eventually. It gets incredibly serious when these shared algorithms start controlling human livelihoods.
And that brings us to a massive, highly concerning Stanford research study. Letting an AI scan resume sounds like the ultimate corporate time saver, right? But this extensive new study showed the hidden cost of that efficiency.
The scale of this study is huge. They reviewed 4 million job applications in total. These applications spanned across 156 different employers globally. All of these employers were using the exact same AI screening tool, It is called Pometrics.
The granular findings showed a very clear and alarming negative bias in the screening. Around 10.6% of the job positions showed a measurable bias against Black applicants.
They also found a 5.3% bias against Asian applicants. Just the sheer scale of automated rejection at that level is deeply troubling.
But the real danger, the thing that makes this a systemic issue, is the hidden cascading effect. 42 of these AI models were shared across different employers.
Getting rejected by one algorithm essentially triggered rejections everywhere else. It affected completely different companies using the exact same underlying system. You applied to company A, got silently flagged, and company B rejected you too.
Roughly 4% of candidates in the study applied to 10 different positions. They were systematically rejected from all of them by the machine.
That is a much higher fail rate than human recruiters produce. Because human recruiters, for all their flaws, make independent choices. They have varying personal preferences and blind spots.
Exactly. An algorithm applies the exact same rigid filter every single time. It creates an invisible, impenetrable wall for certain applicants across the entire job market.
Now, I do want to push back on one thing here. We should note that this specific data has a time frame. The researchers rightly point out the data is from 2018 to 2022. Today's hiring wave is increasingly powered by modern LLMs. Are these older biometrics findings still relevant today?
That is a very fair pushback and an important contextual detail. Modern language models absolutely function differently than older predictive tools. They are much more nuanced, but the core structural danger hasn't changed at all.
Because of the centralization.
Yes, exactly. When 50 different companies rely on the exact same third-party AI vendor to screen resumes, they inherit the exact same blind spots. The specific biases might shift, but the cascading effect remains. That is why keeping a human in the loop is absolutely mandatory.
But is the centralization of AI models the real enemy of fair hiring here?
I would say yes. Identical shared blind spots create systemic walls for applicants. You cannot outsource your entire judgment process to a monopoly.
Basically, never let one single AI vendor be the only gatekeeper. Beat.
Precisely. The underlying technology evolves and gets smarter, but the centralization risk remains completely constant.
Let's take a moment to step back and look at the whole picture. 2-sec silence. We are looking at a complete re-architecture of modern technology right now. On the physical side, we are literally folding logic circuits to outsmart the limits of physics.
And on the software side, we are processing quadrillions of tokens to solve incredibly complex math. We are sending autonomous humanoid robots into major retail logistics networks to move physical boxes.
But as we hand over the keys to these shared algorithms, we risk building massive, invisible walls.
Right.
Whether it's an AI that cannot spell a simple word or a resume screener locking people out of the economy. The overarching theme today is the inherent tension between breathtaking scale and the absolute necessity for human oversight.
It is a delicate balancing act we are all navigating right now. Scale brings power, but centralization brings systemic vulnerability.
That leaves us with a final thought for you to mull over. If AI models inherit blind spots from their centralized vendors.
And we are moving toward a world where platforms like Zero.xyz let thousands of autonomous tools and agents talk directly to each other.
Who is actually auditing the conversations between the bots when a human is no longer in the loop? Beat.
It is the big question. I strongly encourage you to keep questioning the automated systems you interact with daily.
Thank you for joining us on this deep dive.
We will see you next time.